Okay, so this is a video on trigonometric equations. And how to solve them. So let's take an example here. Let's say I have 2 times the sine of theta plus 1, and that this is equal to 0. Okay, so we can solve this fairly algebraically. We subtract 1 from both sides. Gives me 2 sine theta is equal to -1. Divide both sides by 2. And now I have the sine of theta is equal to -1/2. And in the problem that I have in the notes here, I've restricted the domain from 0 to 2 pi, not including 2 pi, because that's going to be the same as 0. So I want to know all the places from 0 to 2 pi where the sine of theta is equal to 1/2. So recall, we can do this by looking at the unit circle. So if I look at my unit circle, and I can see pretty clearly that the sine of theta, right, which is going to be the y coordinate, is at 7 pi over 6, and 11 pi over 6 is -1/2. So this equation on the domain 0 to 2 pi has two solutions. One of them is 7 pi over 6. The other is 11 pi over 6. So I would write that the solution set to this is 7 pi over 6 and 11 pi over 6. This on this domain 0 to 2 pi, not including 2 pi, this equation has two separate solutions. Okay, so the second example that I have in the notes here is a little bit more complicated. So let's take something like 2 times the sine of 2x, right? 2 times the sine of 2x minus x cubed plus 1 is equal to 0. Okay, so this is one where you're not going to find a value on the unit circle that solves the problem, and it's not easily solved algebraically. So what we're actually going to do is we're going to leverage the technology to get us the x value that solves this equation. So what we're going to do is we're actually going to use the graphing aspect of the calculator, and we're going to make this the left side of the equation y1. We're going to make the right side of the equation y2, and we're going to look where the graph, where those two graphs intersect, is where these things are equal, and therefore we'll be able to find the x value that, or x values, that solves this equation. Now, to keep things simple, again, we're just going to limit ourselves to the domain of 0 to 2 pi here. We're going to work in radians to find the solution, and we want a solution to 4 decimal places. All right, so let's take a look at how that works with the calculator. Okay, so just like I said moments ago, I was going to use my calculator. I want to make sure I'm in radians mode. I am. And then I'm going to hit the y equals button. And the left side of the equation, 2 times the sine of 2x minus x cubed plus 1. That's the left side of the equation. I'm going to put that in y1. And the right side of the equation I'm going to put in y2. Now I should do some windowing here, okay? Because I'm restricting my domain from 0 to 2 pi. So I don't want to see anything other than the 0 and the 2 pi. And just to kind of make things easier for me, I'm going to make the the x scale pi over 2. I'm going to leave the y min and y max at -10 to 10, so you'll see what's going on here, and I'm going to graph this. Okay, so this is what this function looks like, and it starts by going up on this domain, and then it just keeps decreasing. There's a lot of this function that we don't see, but what we do care about is where does this function equal 0. So we want to know where that little point is, right there, where this function is equal to 0. Now the calculator can do that for us. The way I do this is I go second trace, and I'm actually going to look for, I could use the 0 function here, but I already put the y equals 0 in there into y2. So I'm going to use number 5, the intersect function. Now if I bring my cursor to the left here, because it's off the screen currently, there you go. You can see that it's following the curved screen, and the calculator is asking me for the first curve. So I'm looking for the intersection of two curves, this one and the line y equals 0. So I'm going to say, hey, enter. I've selected that curve. Now you'll notice the curve jumped to the x-axis, which is the line y equals 0. So I'm going to hit enter again, and it says, hey, what's your guess? And I move my cursor as close as I can to that point of intersection, and I hit enter a third time. And right there, my calculator gives me the x value for where these two things cross, and its y value. It's going to cross at 1.2802, and y is 0. So that's my solution. At approximately 1.2802, this is going to make that equation true. Now, the one thing is that on this domain, there's no other point where that happens, so that happens to be the only solution to this equation on the domain of 0 to pi over, or sorry, to 2 pi. All right, so let's write that properly and we'll be done. Okay, so according to my calculator, the x value 1.2802 solves this equation. If you were to put it in there, it would make this true. There is no other solution on the domain from 0 to 2 pi. So we have solved this equation on its given domain in radians. All right, so there you go. We're going to work with this a little bit in class next time around. But this is a start on solving trigonometric equations. Thank you.